In this video, I'm going to find the derivative of this function using the definition of derivative, and then I'm going to find an equation for the tangent line to this curve at x equals 2. So first of all, recall the derivative by definition is, so it's a limit, f prime x is the limit as h tends to 0 of f of x plus h minus f of x over h. So I'm going to use that here to get this derivative. So for my function, f prime x is the limit as h tends to 0, and f of x plus h is going to be x plus h over 1 minus 2 times x plus h. Then I have minus f of x, so minus x over 1 minus 2x, and that's all over h. Okay, so this is f of x plus h, and this is f of x. Now, surely I need to simplify this. So the first thing I would do is I would pull out that h. Okay, so I have 1 over h. And it has to stay inside the limit, right? I can't pull it outside the limit because it's part of the limit. The limit is as h tends to 0, right? So I need to be able to evaluate. So let's get a common denominator. So this becomes the limit as h tends to 0. I have 1 over h. My common denominator is going to be 1 minus 2 times x plus h, and I get 1 minus 2x. So on the left-hand numerator, I've got to multiply by 1 minus 2x, and for the right hand, I've got to multiply by 1 minus 2 times x plus h. And at this point, I want to stop and give a tip. So here is my tip. Do not expand the denominator, but do expand the numerator. So if we expand this denominator, A, it's a lot of work, and it's unnecessary. And the other thing is it often causes students to make errors. So I generally recommend not expanding the denominator, but we do need to expand the numerator. The whole goal is we want to be able to cancel this h, okay, so that we no longer have an indeterminate form so that we could evaluate the limit. So let's go ahead and expand the numerator. So what do I get? So if I multiply out that first part, I get x minus 2x squared plus h minus 2xh in the first part. And let's see, so in the second part, I've got minus x times 1 minus, I'm going to do this in 2 steps, 2x minus 2h. And like I said, we're not doing anything with that denominator. It remains as follows. So I've gone ahead and simplified that numerator a little more. So I distributed the x through that piece. And now let's go ahead and cancel. So I can cancel those x's, I can cancel that, and I can cancel that. And now what am I left with? So here's what I'm left with if I clean it up. Now, this is great news because I can cancel the h, right? And so now I've got the limit as h tends to 0 of 1 over this. And so now I can go ahead and evaluate the limit because it's no longer an indeterminate form. So what do I get when I evaluate the limit? Well, I have a 1 on the numerator. On the denominator, all I have to do is plug in h equals 0 here, and I get 1 minus 2x times 1 minus 2x So my derivative is 1 over 1 minus 2x squared. Now there was a second part to this problem. Find an equation for the tangent line to the curve at x equals 2. Now we found the derivative, and the derivative can be used to give us the slope of the tangent line at a point, and the slope of that tangent line at the point x equals 2 is given by f prime of 2, which is 1 over 1 minus 2 times 2 is 4 squared. So that's 1 over 9. So that's my slope. Okay, so that's going to be the slope of the tangent line at x equals 2. And of course, to get an equation for the tangent line, you need a point and a slope. So you need a point. You know that x is equal to 2. So x is equal to 2. And to get the y value when x is equal to 2, we need to go back to that original function and evaluate at x equals 2. So recall that the function is f of x equals x over 1 minus 2x. So the y value at x equals 2, the y value is f of 2, which is 2 over 1 minus 4, which is minus 2/3. So you have a slope, 1/9, and you have a point, 2 minus 2/3. And so you can just go ahead and use the point slope formula. So we have y minus 2/3 is the slope, 1/9, times x minus 2. And let's simplify that. So I have y plus 2/3 is 1/9 x minus 2/9. So y is equal to 1/9 x minus 2/9 minus 2/3, or 1/9 x minus 2/9 minus 6/9. So my equation is 1/9 x minus 8/9. So that's the equation for the tangent line at that point.